So hello everyone. Today we are going to see about the process in operating system. So what is process? The process is nothing but which program is in the execution. So for example, if suppose you are typing the arithmetic operation in a C program, you typed in your system. After typing your program, you need to compile the program. So press F9. After the compilation is over, you press Alt R for executing your program. In this case, your typed program is the source program, and after compiling, the program is to be created as the binary file. That means the object file. The object file only is to be executed in your CPU. That program is called as the process. Which program is going to be execute, which program is processed under the CPU, that program is called as the process. In our computer, we may have so many number of process. So for example, if which process is to be acting, that process is called as the active entity, the another one is called as the passive entity. For process, it have the structure. The process structure is to be classified as the text, data, heap, and stack. The text section is contain the code segment we already explained. Likewise, if we type the C program for arithmetic operation in your system means the typing the program is called as the text or code segment, and then the stack is the temporary data storage. It is if we use some functions or written arguments that are all accessed in the stack, that are all stored in the stack. The data section is consist of the global variable of your program. The heap section is used for the dynamic memory allocation of your process at the running time. If your process is to be executed successfully, the memory is to be deallocated. The process state is to be classified into new, ready, run, and terminate. If suppose now we are typed the arithmetic program in a C, the program is typed 1, and now we compiled it, we need to execute. So now it is a new, the object file is to be created. Now we need to execute that file. So that new process is called as the new process. And now we are going to execute that program. So it is called as the ready state. After that, we executing the program as the run state. If there is any interruption, it may be terminated successfully. It is a one kind of process execution. So here we view the 4 states of the process: new state, ready state, run state, and terminate states. If suppose it may be classified into primitive and non-primitive. If suppose it may be the another type means if the process is under the running state, the particular process may need themselves some IO device request. So here the process suspended itself, or the process moved on from the processor and it hold in the wait block. Here when the process getting the particular IO response, then only it will again move on to the executions. So here the particular process is to be hold in the wait or block. It is called as the wait state of the process. It may be occurred if suppose the process themselves they need some IO request, or sometime any other higher priority process interrupt the particular running process. On the time also the running process may hold it in the wait state. The higher priority process is in the execution. So this is the another method. And next one. If the wait block is to be full, we already seen if at the time of running the process, the particular process is need some IO request, it moved on to the wait block because we never make the processor as an ideal one. We execute another process in our another process in a processor. So we never hold the CPU as a idle. So automatically the process is moved on to the wait block. If suppose the wait block is full, that means so many processes are in under waiting for execution. So if the wait block is full, automatically the new, for example, we are going to run the process 3. The process 3 is moved on to the wait 3 state, but the wait block is already full, then the process 3 moved on to the suspended wait block. Here, if suppose the suspended wait block is ready, or otherwise the wait block, the some process is to be moved on to the ready state. Now the wait block have some space, then the suspended ready, we already placed the P3, the P3 process may move on to the wait block, and then the P3 is moved on to the ready, and after that it moved on to the run and terminated. In this another case, if after reaching the wait, it moved on to the ready state, the ready may be the full, the ready may be not having the place, means from the main memory to the P3 placed into the secondary memory, suspended ready queue. So when the ready queue is to be have some space, and that time the P3 moved from suspended ready queue into the ready state, and then it moved on to the running state, and it moved on to the terminate state. So this is the states of the process. So if there is no interrupt at the time of process execution, the process is neatly moved on new ready run terminate states. If suppose any kind of interrupt occur, it may move on to the wait state, or it may be moved on to the suspended wait. It is swapped into the suspended to wait, wait to ready, and ready run terminate. So sometimes suspend wait to suspend ready, and ready queue run terminate. These are all the process states. So here we explained about process. So new is which program you now newly created. The program which is ready for execution is called as the new process. If the process is prepared for executing, means it is the ready state of that particular process. The CPU running the process, in our example we see in the process 3 P3, so that is the running process. If suppose the P3 is interrupted by some other process P6, P7, so then the P3 is to be moved on to the blocked state or waiting state. Not only the interrupt, suppose P3 needs some IO request, until the IO responded, the P3 hold themselves. And the next one is a suspend ready. If the waiting block is full, then the P3 is to be placed in the suspended ready queue. Likewise suspended ready swap also. And then exit is to be the execution of the process is to be success completely, then it will be terminated. And the next one is the process control block. The process control block is a data structure by the operating system to keep the track of process information and manage the execution. So in a previous we look at what are all the states of the process. The states of the process is to be monitored by the operating system, which process having the priority, which process need to execute. For all these details are needed to maintained by the operating system. That structure of that organization is called as the process control block. The process control block is assigned the process ID for each process within the processor. And then the process control block store the details such as the process state, program counter, stack pointer, opened files and scheduling informations of the process. And then during the transition, the OS updates the PCP with the latest execution data. For example, in past we see the P3 is to be in the execution state, but due to some IO request it moved on to the wait state. Yes, so in this case P3 in the running state, but now the P3 is in the waiting state. So these fraction of changes in the process information is to be maintained by the operating system. This information is maintained within the PCP. The PCP is having all the details of that process. It is also include the register values, CPU quantum and the process priority. The process table is an array PCB that maintains the information for all active processes. So here we are seeing the structure of the process control block. So the process control block is organized in this way: the pointer, process states, process numbers, process counter, registers, memory limit, and a list of open files. So the structure is explained here, and then the pointer is stored the pointer value at the current address of that process. The process state, which we see so many processes in our memory, so each process state is to be maintained in the process state block. And then the process number, we already seen the PCB is assigned the PID, process ID, for each process. That number is to be maintained in the process number. The program counter is used to address the states of that counter, which contains the each process status. The register, so if we are in using the memory, means the local variable is to be assigned under memory registers. The registers are used by the several process. So the process are executing on the CPU. The variables has to be stored on that register. After the execution, the register may be the cleared, and then some other process may use it. So what are all the process acquired, the what are all the register, these informations are is to be stored in that register. The memory limits, so the limit of the memory is to be assigned for that process is also maintained. Memory management system is to be managed by the operating system. And then list of open files, how many files are opened, and currently the informations are stored here. So these are the informations having in the process control block. Thank you.